Hello dear students, this is Shanti and I am working as a maths teacher at ZPHS Kukumpeta Rajamundry Rural. This video is created along with Aaron. Today I am going to tell few concepts regarding quadratic equations. Before getting into quadratic equation, let me recapitulate what is a quadratic polynomial. So any polynomial of degree, we call it as quadratic polynomial. And if we equate that quadratic polynomial to 0, we will get a quadratic equation. The general form of a quadratic equation is ax square plus bx plus c is equal to 0, where a comma b comma c belongs to R and a should not be equal to 0. Also, y is equal to ax square plus bx plus c can be called as a quadratic function. So any equation of the form px is equal to 0 of degree 2, we can call it as a quadratic equation. We have many mathematicians who dealt with this quadratic equation. So Babylonians were the first ones to get the solutions for these quadratic equations. And the Greek mathematician Euclid had gone to a geometrical approach to find out lengths and breadths using these quadratic equations. And Brahmagupta is the one who found out the general form of the quadratic equation ax square plus bx plus c is equal to 0. And Siddhacharya is the one who found the quadratic formula, or in order to find out the quadratic roots, he discovered the formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Now let us get into the solution of the quadratic equation. If alpha is any real number and we have the general equation ax square plus bx plus c is equal to 0, and if we substitute alpha into this equation, now if a alpha square plus b alpha plus c is equal to 0, then we can call it as alpha as the root of the quadratic equation. Here x is equal to alpha is the solution of the equation, and we can find the roots of the quadratic equation using the formula as I have mentioned earlier, by using the formula minus b plus or minus square root of b square minus 4ac by 2a. In fact, at most we will be having two roots for the quadratic equation. Both the quadratic polynomial and the quadratic equation have the same number of roots or zeros. In terms of quadratic polynomial, we have zeros, and in terms of quadratic equation, we have roots which are same. Both are same, and the graphical representation is a parabola in fact. And we can write the standard form of a quadratic polynomial by looking into the degrees of the quadratic polynomial. That means we need to arrange them in the descending order. If we write the powers in the descending order, we will get the standard form of the quadratic equation like ax square plus bx plus c is equal to 0. Now, the next topic is nature of the quadratic equation. How can we define the nature of the quadratic equation? We can define the nature of the quadratic equation using discriminant. Discriminant is nothing but b square minus 4ac. So, by using the value of b square minus 4ac, we can define the nature of the roots. Here, a is the coefficient of x square and b is the coefficient of x and c is the constant in the general form of the quadratic equation ax square plus bx plus c is equal to 0. Now, if the discriminant b square minus 4ac is greater than 0, we will get a distinct and real roots. Now, in this case, we can find out the roots by using the formula minus b square root of b square minus 4ac by 2a. And if we see the graphical representation, we can see the parabola will be touching x-axis at 2 points, which means every quadratic equation when the discriminant is greater than 0 will be having two roots at two different points. Suppose when b square minus 4ac is equal to 0. Now in this case, the roots will be equal. Now if we see the graphical representation, we can see the parabola is touching at a single point. That means both the roots are coinciding at one point. And we can find out the roots by using the formula minus b by 2a. Now the third case is when the discriminant b square minus 4ac is less than 0. In this case, we don't have any real roots. And if you see the graphical representation, we can see that the parabola is not touching x-axis, which tells that the quadratic equation won't be having any real roots. Thank you.